So, hello everybody, my name is Sitraka Forler, and today we are going to see and speak about with graphics about a data science project on a visual point of view, the importance of a loop rather than a model, because too many videos focus only on the model, while I think it's a little bit more complicated than that. It's more about the question, the problematic that you have, the data then, the cleaning, the model, the evaluation, the deployment, the monitoring, then the refinement. So it does not start with the data. I'm saying this because too many times, too many years, the main quote was data is everything. Data is the new gold, it's the new oil more. It's more like oil because it needs to be refined. And it's just like oil, you we didn't create the car because oil was found. It's because we had a car that needed a good combustible that we used oil. So it's a bad start to say we have all this data, let's do some machine learning on it. Too many projects started like that and too many of them failed. The good start will be just like in English or in French. You need to have a decision, a question, and a metric. So, for example, the decision which loan application should a human review? Question, can we rank application by risk or default? And the metric, cost of missed defaults versus controlled and manual reviews. So, again, the first point is decision, then question, then metric. In that order. The metric is chosen before the model. If no decision changes when the project succeeds, then the project has no point. Like, we need to have a star, the Shepherd star, North Pole star. The shape of the project is a loop. So every arrow forwards has a matching road. So we need 6 points in theory, but I think it's more precise to say 8. First of all, we have the question. Then we need to get the data, clean it, explore it. So this is the EDA, and this then comes the model. So in blue, it's more data engineering and data analyst in some companies, but it's more data engineering part than fully data scientist. Then you have the whole thing, which is the real data ninja slash data scientist go. So the model, evaluate, deploy, monitor, learn and refine. We will see it a little bit later. All that to say that it's a circle, so it's a cycle too. You learn and refine to have better question. So evaluation sends you back. The better the data, the better the question, and it's rarely the fancier model that wins. It's the best used case that wins, in fact. So you need to plan to go around the loop at least 3 times. One really simple way, a more clever one, then a complex or tailored one. So where the time actually goes. So if you ask everyone in the field, in the data science field, he will tell you it's a data analysis part, it's a data mining part. You need to understand and clean the data. So it's EDA. Then you need the joining, the features, and exploration. Then comes evaluation, communication, and the model. Only 15%. It's of course it's not exactly 15%, but let's say it's a small part. It's a small part. It's a small box, and the box only goes once at a time. So you need to budget the project like those bars. You need to understand that it will take some days to get that part, and then that one, and then that one. So also you need to never forget to split the data before you touch anything. There is an Italian guy named Pareto, and I think his rules are pretty good, like the Pareto rule. So most of the time I say it's 80-20%. 80% of the data must be used for train, the past, and 20% must be still virgin of everything to test it later and be aware that there is a risk of leakage. So it's really dangerous, and it's even more dangerous with time series. So you need to split and shuffle it even more with market data and to be really precise about the dates. A leakage test can be really painful in the ass at the end of the project. So you earn the right to be clever, what does this mean? It means what I tried to say in the first slides, which is you need to first try the naive, so the dumb test, the dumb models. You need to predict the majority class, then yesterday value, logistic regression, and then the more tailored model. The fancy model cannot clearly beat the naive ones, then you chip the naive one, so, because it's more cost efficient. So you need to evaluate the decision and not the leaderboard. So 99% accuracy can still be useless. And one of the best example is a lot of projects in banking industry for transaction monitoring. For example, you have 1000 transactions and only 10 frauds. So if you score a 99% accuracy, it catches their fraud. And if so, it's a failure because you have 4 existing potentialists. So you need to pick a clever metric and not only accuracy. So you need to have it in the business currency. You need to be clever about it because it can cost money. And if it fails all test, even if it's better if it fails test and that you can improve it rather than not failing it. Complexity is a loan you repay forever. Every extra moving part must pay rent. And that's a mechanical adage. And I think it's true in data, informatics, and everything. The more parts you have, the more complexity you have, the more pain in the ass you will have. And sometimes you will reach a tipping point. It's decreasing marginal returns. So, once again, Ricardo, it's also like Pareto. Those are names you must know forever. A model you cannot explain is a model you cannot defend when it's wrong, and that's a painful thing for the direction committee, and it will be a painful thing for you too. So you need to start with the linear regressions, then add complexity, most of the time logistics, and then you will see XGBoost or anything. But deployment is where the project starts really aging. The world moves, it's a dynamic world. When you die, the world still continues to move. It spins around. So when you launch it, there is a big risk that your live accuracy will decrease. And what's the name of it? Well, it's called a data drift. The inputs stopped looking like the training test, the training set. So the more time goes and the more useless is your model. So a project that ships with its monitoring is key. You need to monitor everything every day, every second. A model without monitoring, well, I'm biased, but a model without monitoring is a slow outage nobody assigned an owner to. And guess what? You are blessed because now more and more tools are cheap or nearly free, weighted biases, to see the best of it. So the deliverable is a decision, not a notebook. What you are paid for or what value you bring is not only the technicality. The technicality is just a tool. It's a process to get to the value, which is a final decision. So remember only 4 things: what we asked, what we found, how we are sure of it, how we test our hypothesis. It's like econometrics, but with way more data. So it's machine learning. And what we do, what to do, what are the recommendations in one sentence. Because you need to just remember that slide, to be honest, because if a decision maker cannot repeat your conclusion in one sentence, it did not land in his head, and it will just be terrible for you because he will see data science as a cost, a fancy cost that his company cannot afford or is not really the priority of the company. So you need to start with a question, with a problematic. You need to split then first the data. You need to beat the naive models. And then when you ship the model, you need to think of monitoring the model and monitoring everything that is happening. So the model is the smallest box, less than 15%. Evaluation sends you back in the cycle, 8 points. And then the deliverable is a decision. You do it in order to create value, not to make some lines of code, even though with AI it's now faster to do it. So practice the whole loop. You can do it for free with overfitting, backtesting, honest metrics on ecofinlearning.com. You just go on the machine track and you have a capstone project. So have a good day, and I hope this video was